Welcome back. In the last video, we finished off checking out our correlation matrix, and we looked at our workflow and saw that we're now up to step 5. So we've covered problem definition, data evaluation, we've looked at the features, we've done a little bit of data analysis. Now it's time to start bringing in machine learning. So let's see how we do that. Let's go into here, we'll create a little heading. We might do it 5.0, modeling, and we're going to turn this into Markdown. And so what's our problem? So let's scroll back up. We defined it up here, right back at the start. So problem definition is step 1. So in a statement, given clinical parameters about a patient, can we predict whether or not they have heart disease? So we're working with a classification problem. Okay, that's what we're trying to be answering with machine learning and evaluation. So this is our evaluation metric, because right now we've got a data set and we're just exploring it. We're experimenting here. So if we wanted to actually get this into production, into a real life setting, we'd probably want it to be fairly good, right? Because it's predicting something as important as whether someone or not has heart disease. So we would want a minimum of 95% accuracy at predicting whether or not a patient has heart disease during our proof of concept, which is kind of what we're working through here. And if we can make it to that, we'll keep pursuing it. We'll keep going, see if we can improve it, make it better, or see what we need to improve. So this is what we're going to be trying to solve with machine learning. We're trying to answer this problem statement. And this is our evaluation metric, something that we'll be working towards. And of course, each of these could change, but these just give us a little roadmap of something we can head towards. So let's go down, see what we would do. The first thing we might do is re-look at our data set, remind ourselves of what we're doing. So we're going to be using these columns to try and predict the target column. So aka the independent variables to predict the dependent variable here. And the first thing we might do is split our data into X and Y. So we'll split it into features and labels. And then what we might do is create a training and test split, similar to what we did in the scikit-learn section when we worked through the scikit-learn machine learning workflow. So let's do that. So let's go split data into X and Y. X is going to be equal to every column except the target column. That's what we want. So df.drop, we're going to drop the target. We're going to set the axis equal to 1. Beautiful. And then Y is going to be, these are all the labels. So we're going to go df. We can just go target. There we go. Now let's visualize X. Wonderful. No target column, and we'll visualize Y to remind ourselves it's just 0 or 1, whether or not someone has heart disease. So it's a binary classification because there's only 2 options. Binary meaning 0 or 1. And now, what we have to do is split our data into a training and test split. Now, we've seen this before, but it's worth reiterating. Why not use all the data to train a model? What is a train and test split? Well, let's say you wanted to take your model into the hospital and start using it on patients. How would you know how well your model goes on a new patient not included in the original full data set that we have? So if we built a model on every single sample in this data frame, how would we know? How would we have an insight into seeing how it would go on someone that our model has never seen before? This is where the test set comes in. It's used to mimic taking our model into a real environment as much as possible, or at least it tries to as much as possible. It's important to never let our model learn from a test set. It should only be evaluated on a test set. So we're going to have a training set, which is like when you're studying for an exam, it's like the course material. So the machine learning model is going to learn the patterns in the course material. And then it's going to be evaluated on the final exam, which is the test set. So let's see that. What we're going to do is split data into train and test sets. So to do so, we can use NumPy random seed first so we can reproduce our results. And we can split our data into train and test sets using scikit-learn's train test split. So we go split into train and test set, xtrain, xtest. We saw a lot of this in the scikit-learn section, but it's paramount to reiterate that that whenever you try to test or whenever you try to evaluate your model, it should be on data that the model has never seen before. Test size, we're going to do the standard 0.2. So this X is what we've created up here, our dependent variable, and this is Y, which is our labels. So now we're going to Shift and Enter. Wonderful. And we're going to have a look at the training data. So we'll go X-train. We can see that it's shuffled it and it's got 242 rows out of the total 303 rows. So it's got about 80% of the entire rows. Then we can do the same with the Y-train, and we might find the len of Y-train as well. Y-train is the same length as X-train, but it's only got the labels. And so if we compared the indexes here, it's got the labels for each of these samples. 132, 132. Wonderful. Now, what do we do? Well, now we've got our data into X and Y. We've got train and test as well. So we've got a training data and we've got testing data. The next thing is to build a machine learning model. And, we're working with classification. This comes to a point where it's like, what model should we use? Now we've got our data split into training and test sets. It's time to build a machine learning model. We'll train it, so find the patterns on the training set, and we'll test it, use the patterns, so using the patterns it's found on the test set. But what machine learning model should we use? Well, if you remember in the scikit-learn section, we checked it out, the scikit-learn machine learning map. So we're going to go in here. Wonderful. So this is our start. So if we followed this through, we know we've seen this before. We've got a classification problem. We're trying to classify whether or not someone has heart disease based on their health parameters or based on their medical parameters. So what we might do is only try a few of these. You could try all of them, but what we're going to try and do is use K-neighbors classifier. We'll use this one. So if we open that in a new tab, and then we're going to also use our trusty random forest. So we'll open that as well. So ensemble methods, there's a random forest in here. Random forest classifier, that's what we're after. Yes, beautiful. And we got here the nearest neighbors. Wonderful. So if we look through that, we'd see how we could use it, but we're going to see this in practice. But there's one more. If we go back here, back to our machine learning map, and it's not listed on here. I wonder why that is. Well, we're going to see it in the next video, what it is. I'll give you a little clue. It's called logistic regression, and you might be thinking, hey, we're working on a classification problem. Logistic regression has the word regression in it. And why isn't it in this classification part? Well, that's a great question because I'm not really sure either, but we're going to have a look at those three models in the next video. So we'll create them and we'll see how each of them goes, because remember, we're experimenting now. We're in our modeling/experiments phase. And one part of the experiments phase is trying different machine learning models. So that's what we're going to do. We're going to try 3 different machine learning models and see how they compare with their results on the test set. And then, of course, we want the best one. So let's do that.